So let's start this. So before attending to the transformer sizing or a battery and battery charger sizing, DG set sizing. So what is the input you required to size the transformer team? Generally, you require the load. So what are the loads to or connecting here? What are the loads? Now, let's in a simple way, I am sizing the auxiliary transformer for some city A. In this city A, I am having 6 houses. 6 houses. These 6 houses having some demands here. The first house having some required some X kilowatt, and city house 2 required some Y kilowatt, and 3, 4, 5, 6 similarly Z, P, Q. So the capacity, the load required by the individual houses differ. This actually required X kilowatt, this required Y kilowatt, Z, and so on. And also, if you see this house is installed capacity is X kilowatt, but you don't know when they are using this X kilowatt. Maybe today they are not in the city, they went to their outside of the city. So for now, this X kilowatt is not there for time being. And only these loads are there for up to 1 month. Not only that, morning, the house 2 are having more load compared to all. At evenings, house 2, they are not turning on the lights. So the load will fluctuate. We cannot expect the load. We cannot expect the load unless it is a same process. Suppose, let's see in the substations. If I'm talking about the substations, after 6, every day, all lights to be on. We know that load. We know that load. The load of lights outside the switchyard or will be on from 6 p.m. to morning 6 a.m. 12 hours load. We know this. And we also know the some loads that daily during the office hours, maybe in the substation, the staff will be there. So from morning 10 a.m. to evening 6 p.m., I required some loads for laptops, connectivity, for the fans, lights, everything. These are some loads daily. So these loads are some, we can call it as a non-continuous loads. These will be there only for period of time. And if you see the relay operating coils and or master trip relay, this generally we have trip circuit supervision. These are continuously monitoring relays. These relays generally require continuous supplies. So these are continuous for period of 24 hours, 365 days. These loads will be there. 365 days. These loads will be there. These are continuous loads. If I'm talking about the substation. And these are the non-continuous loads. And some loads will be there. Non-continuous loads can also be like operation of firefighting pumps. These motors will not run daily. If a fire attack is there, then these motors will comes into the play. So that also non-continuous loads. And apart from this, we are having some loads which we will call as a momentary loads. The momentary loads in the sense like operation of the circuit breaker, operation of the isolator, which will exist only for 1 minute, maximum 1 minute. The opening time of a breaker or closing time of a breaker is 60 milliseconds to 120 milliseconds. So this for 1 minute, only for a period of 1 minute maximum, there are some loads like breaker operation, isolator operation. These we will call as a momentary loads. So in a day, there would be some load curve which will define when the load will come. Suppose if I know this, I can say that morning 6 p.m. there are only continuous loads, and after 10 p.m. to 10 a.m. to 6 p.m. there are some loads, and after 6 p.m. these are the some loads up to 6 a.m. These are to do the lighting. These are for the staff requirements, and these are the continuous loads, and these loads will continue like this. And this is the margin. This is the loads due to the lights, and this is the loads due to the lights plus staff plus continuous loads. This is lights plus continuous. So this is how you can see the curve. The same curve, if you see for the industries, you are operating the motor for some period of time. Like suppose if I want to manufacture some 10 cylinders, I have to cut the cylinders. So those motors will work depends upon the raw material exist in your plant. Suppose daily you are having some process that I have to cut 50 pieces. So 50 pieces are cutting by that machine for some 3 hours. So that machine is working only for 3 hours. The cutting machine for the cylindering manufacturer, the raw material will be there. It has to cut 3 for suppose it's 5 meters. So this is cutting. It is working for only for 3 hours, this machine. And these pieces are transforming to the next one until that machine will be idle. So it will work for next 3 hours. And for the molding, so all these machines are having some period of time. So we cannot say, suppose if you do the sizing for all the machines by taking the maximum loads, all the machines maximum loads, that will increase your capacity of the transformer. To do the optimization in this here, you have to know some factors here. Those factors we will call as a demand factor, or there are so many factors. Demand factor, you already know these terminologies, but again I am repeating basic things. Demand factor, load factor, diversity factor, capacity utilization factor. So these are some factors you generally read in the articles. So load factor, first of all, I am talking about the load factor. Load factor is generally applicable for the power system industries, like load factor and capacity utilization factor are similar to for the power generations. For load factor in the sense, average demand by maximum demand. And capacity utilization factor is how much megawatt you are generating from the solar plant. What is the installed capacity of the solar plant? Suppose daily suppose for today I generated only 30 megawatt of 30 megawatt from 100 megawatt. 30 megawatt from 100 megawatt. So the capacity utilization factor is 30%. On average, you can see for a whole period of time. So that gives you the CUF, capacity utilization factor. Generally, the solar plants, the capacity utilization factor is 19%, 20%. For the wind, maximum you can see 30%. Because these are not a raw material, means these are non-predictable. Even in the summers, sometimes due to the cloud passings, the generation of the solar comes down. You cannot expect high generation even in the summers. And this cannot be predicted. These are the seasonal changes. And if you see the wind, the season will be June, July. These 2 months only you can see 90% of the generation, the capacity utilization factor 90% on average for June, July, August months. In the rest of the months, you won't believe that from the wind for 100 megawatt of wind plant, you can get only 16 megawatt, 8 megawatt, even 6 megawatt sometimes. The capacity utilization factor is this. If you check the coal, the capacity utilization factor is more because you are having the raw material with you, the coal. Hydro depends upon the rainy season, the water content, again the source. The capacity utilization factor is that. What is the megawatt you are generating? But what is the installed capacity of your megawatt? That is a capacity utilization factor. And the remaining two things, the demand factor or diversity factor, are very important during this auxiliary supply distribution, or if you are trying to build the electrical system for apartments, for the residential buildings, offices, and for the plants, the demand factor and diversity factor are very, very important. Let's see that. What is the demand factor? What is the diversity factor? The demand factor is, again, the maximum demand of the system, by total connected load on the system. The maximum demand of the system by total connected load on the system. So the maximum demand by total connected load gives always less than 1, right? The demand factor always less than 1. By this, you can see that always this demand factor is less than 1. Suppose I am having a house that 6,000 watts equipment connected. This is a connected equipment. But the maximum demand of this equipment is only 3,000. So what is my demand factor? Only 50% is my demand factor.